Hi everyone, our team name is Monkey Spanner. Our team members are Shiryong and Seokwan. We're gonna talk about a Cassava disease classifier using convolution network. My name is Shiryong. Let's start presentation. This presentation will proceed in the following order. First, introduce. Second, description of datasets. Third, introduce of CNN architectures and models. Fourth, we will talk about result of model training. Finally, we discuss about how to we build lightweight deep neural network models. What is the drink name you see on the PPT slide? Yes, it's bubble tea. Have you ever had bubble tea? Its main raw material is obtained from cassava. We will now look at the problems cassava suffers from. Cassava is a subtropical crop native to South America. Its roots are rich in carbohydrates and leaves are rich in vitamins, so it is grown and consumed in many regions, including Africa. A recent outbreak of an epidemic in cassava farms has caused famine with massive yield losses worldwide. In particular, as cassava production in Nigeria is high, the damage is also high. In the past, the diagnosis of cassava disease by professional personnel was expensive, and it is known that this problem can be solved with CNN classification model. Cassava disease can be classified into four representative types: cassava mosaic disease, cassava bacterial blight, cassava brown streak disease, cassava green mottle. Cassava disease presents visually recognizable symptoms on the leaves. Due to these characteristics, a predictive model can be created by training the leaf image. By comparing various CNN models, we analyzed which model is best for cassava disease classification. Cassava datasets consist of three types: train, test, validation data. And a total of images are 9,449. Images go through three stages of preprocessing. First, it sharpens the image through filtering. Second, resize the image to 224 by 224. Third, to check the image, change the color space of the image from BGR to RGB. There are several ways to represent the color space of an image, such as RGB, BGR, HSV. Next, I will explain how the CNN we will be using is basically configured. CNN mainly consists of feature extraction and classification processes, and feature extraction consists of convolution and max pooling processes. The model we are going to look at is as you can see. And I pass presentation to next presenter, Seokwan.
Firstly, the model we will look at is DenseNet. DenseNet connects every layer with other layer during the feedworthy. And proofs of DenseNet is as follows. The Vanish gradient problem can be alleviated. Picture promotion can be strange. You can lose a picture. The number of parameters can be reduced. Nextly, we will talk about ResNet. There is various variation depending on the number of layers, and ResNet on 115.2 with 115.2 layer is commonly used. ResNet was corrected based on VGG 19 model. The model architecture is as follows compared to NasNet. NasNet is connected picture throws connection, so the channel of output picture get bigger, and NasNet add picture draws the connect. Next is Xception Model. Xception is abbreviation of Inception. It is a newly created Inception model by sampling the model using Inception V3 and modify the structure of the deepwise separable combination. For mobile net, we focus on improving the performance of small model by utilizing deepwise separable combination. The model structure is shown the figure. Next is Inception version 3. Inception version 2 and version 3 are improved model by Google that adopting a part of VGGNet architecture, increasing the model size, increasing the amount of computation. With this disadvantage, when using model device or limited memory, so the Inception V3 model is 42 layer deep neural network with fair parameter and has similar computational load to VGGNet. This followed running with lost memory. Next, NasNet Model. Neural architecture search is method to find optimal neural network architecture using reinforcement learning and RNN. This method has this advantage that is too long for large data. So ResNet is method that find conversion blocks from the small data set and then apply it to large data set to increase the efficiency. Inception ResNet is a new hybrid model proposed by Google, influenced by ResNet, and memory and computational cost is said to be almost double that of the over Inception V3. Inception ResNet V1 and V2 have the same over structure. However, Steam and block use are slightly different. VGGNet is model developed by VGG, a research team at Oxford University. It is divided into VGG 19 and VGG 16 according to the number of layers. The structure look like the following image. Model trained process as shown in the slide. As a result, in terms of accuracy, Inception ResNet V2 show a very good performance compared to other CNN algorithms. As for the training time, the Xception Model took less amount of time. What you are interested in is the weight loss of the model. I was wondering why the various model examined in the model morning learning result had so many parameters, but the learning speed was fast, and I was surprised by the avoidance of the exception model for VGP mentioned in the recent class. We thought about how to solve the problem that arises in modeling. I want to focus on losing weight of the model in the future. Thank you for watching and listening. Bye.
Bye.